see what is isomerism. Isomerism is basically where two or more compounds have same molecular formula but different structure and different structural formula. Okay, we shall see what are the types that are there in isomerism. Let us proceed further. I'll just share the screen. There is a basic classification chart that we have writing isomerism over here. That is our heading. I'll just write the definition. The phenomenon where two or more compounds have same molecular formula but different structure or structural formula also, you can say, because if you have studied some part of the organic chemistry, the basics of it, that we have structural formula in organic chemistry, and we write the structures, we write the structural formula when we are dealing with the organic reactions. Okay, so but different structure or structural formula is called isomerism, and the compounds that exhibit this property, they are called as isomers of each other. Now, isomerism is classified into two types. The main two types are structural isomerism, and the other one is stereoisomerism. So we'll write that here. We'll write the classification chart as well. Okay. So there are two main types. So in this, we have structural isomerism, and here we have stereoisomerism. We are going to see the meaning of each and every term that is involved over here. We're going to see the types also, because structural isomerism is again classified into 4 types. And stereoisomerism is again classified into 2 types. Let us see. Structure, the name itself is telling you that it's something related to the structure of the compound. So your types, as I said. So let us see. The first one that we have in this is chain isomerism. Then we have position isomerism. The names are given according to the meaning of all these terms. Okay, so we are going to see that also. Chain isomerism, position isomerism. The third one is functional group isomerism. Last one is metamerism. Make it very systematically so that when you open your book, you like your notes so much that you should feel that, yes, I should study from my notes. My notes are written very systematically and in a very organized way. And that is what I tell all my students whenever you are taking the notes, while you are writing, while you're listening to the lecture, make it more systematic. This involves good engagement of your mind into the lecture that you are attending. Other thing that I would like to say about stereoisomerism is it has 2 types. As I already told you, sorry, it has 2 types. Okay, and these 2 types, both of these types are discussed in detail in class 11. As far as in class 12, sorry, both of these types of stereoisomerism, they're discussed in class 12. One is geometrical isomerism. Another one is optical isomerism. Okay, so we're going to see the meaning of all the terms here. Even I'll show you geometrical and optical. In NCERT grade 11, only these 4 are discussed, and these 2 are discussed in grade 12. However, we are going to study all of them now. Coming to the first type of isomerism, that is the chain isomerism, as written over here. The first one, chain isomerism. Let us see what is this. The word itself is telling you that it is related to carbon chain. So right there, two or more molecules having same molecular formula. Of course, in all of them, the molecular formula remains the same. Okay, two or more molecules having same molecular formula, but different carbon chain, or in many books, the word carbon skeleton is also written. The meaning of both is same carbon chain or carbon skeleton. So two or more molecules that have same molecular formula but different carbon chain or carbon skeleton are called chain isomers of each other. The phenomenon is called as chain isomerism. The one important thing that I would like to tell you is you will not understand what does isomerism really mean if you don't study the examples of it. तो हर isomerism का example आपको पता होना चाहिए कौन से examples में ये isomerism है, right? So here I'm going to share with you the example of pentane. Okay, pentane, the name itself is telling you it is an alkane having carbon-carbon single bonds. Okay, so the molecular formula we are going to write after we write the structural formula. As you can see, there are 5 carbon atoms. And how many hydrogen atoms? There are 12 hydrogen atoms. C5H12 is the molecular formula of this. However, this structure can be written in this form as well. Notice the carbon atoms are still 5. Hydrogen atoms are still 12. 6 and 6, 7, 8, 9, 10, 11, 12. There are 12 hydrogen atoms and 5 carbon atoms. Still, it is C5H12 only, but the structure is different. The carbon chain is different. Here, the carbon chain has 5 carbon atoms. Here, the straight carbon chain has 4 carbon atoms. One more structure is possible for this with 2 branches. Here, we have given 1 branch, as you can see. Okay, the name we can give 1, 2, 3, 4. What can be the name of this compound? This is 2-methyl or 2-methyl butane. This is butane. However, this is N-pentane. The first one is N-pentane. The second one is 2-methyl butane. The third one is what? Please draw the carbon atoms properly. Yeah. So your this is also C5. Okay. C5H 6, 7, 8, 9, 10, 11, 12. H12. What is the name of this particular compound? Here in the first case, it was pentane. Here it was butane. Here it is propane. Okay. If I number it 1, 2, 3, what I'm going to get, what will be the name of this? 2, 2 dimethyl propane. 2, 2 dimethyl propane. Notice the carbon skeleton or the carbon chain is different, and hence they are called as what? They are called as chain isomers of each other. Easy. The second type of isomerism that we saw was position isomerism. Let us write that. Position isomerism. The name itself is telling you it is related about position. Okay, so two or more isomers that are two or more isomers that possess same molecular formula, of course. I'm just writing MF, same molecular formula, but they differ in the position of substituents. You know that branches are also called as substituents or functional group. Two or more isomers that possess same molecular formula, but they differ in the position of substituents or functional group are called as position isomers of each other. Of course, the phenomenon is called as position isomerism. Example, we are going to see example C3H8O. Okay, now C3H8O is a molecular formula of propanol. If you check propanol, let's check it out. Okay, 1, 2, 3. First position, I'm putting OH. Okay, remaining I'll be putting hydrogens. Let us check. C3, 5, 6, 7, 8, H8O. This is called as propane 1-ol if you check. 1, 2, 3. It is prop, okay, because it is alcohol, it should be having ol as the suffix, and carbon number 1 bears that oh, so the name will be propane 1-ol. Similar to the structure, we have propane 2-ol that has the same molecular formula C3H8O. Let us check that. 1, 2, 3. I'm putting OH here at the second carbon atom. Okay, check it out. You're also H welcome. Notice the molecular formula C3 678 H8O. The name of this alcohol will be propan 2-ol. Okay, and notice they are having same molecular formula, but their structures are different, and they are different where they are different in the position of the functional group, and hence they are called as position isomers of each other. The third type of isomerism that we have is functional group isomerism. The name itself is telling you two compounds that have the same molecular formula, but they differ in the functional group. Okay, they differ in the functional group. They are called as functional group isomers of each other. So two or more molecules having same molecular formula, but they differ in what? In the functional group. They are called as functional group isomers of each other. Easy है? एग्जाम में you can get different examples and you can get the types in the MCQs in the objectives. या फिर ऐसा नोट आ सकता है, write a short note on position isomerism and give examples. Like in 11th standard exam they give like this question. Of course नीट की अगर बात करें या कोई एंट्रेंस एग्जाम की बात करें तो वहां पर तो आपको एमसीक्यू पैटर्न में आएगा, एंड वहां ज्यादा कंफ्यूजन होने के चांसेस है बिकॉज आपको एग्जाम्पल्स देते हैं और चारों आइसोमेरिज्म एक साथ लिखते हैं, तब आपका माइंड कंफ्यूज होता है. तो ऐसे केस में व्हाट यू हैव टू डू इज आपको पहले आंसर ढूंढना है. अगर आपको दो आइसोमर्स दिए हैं तो पहले देखना है कि ये इसमें कौन से टाइप की आइसोमेरिज्म है और इनका मॉलिक्यूलर फॉर्मूला क्या है, एंड देन सर्च और आंसर इन द गिवन ऑप्शंस. इफ यू डायरेक्टली सी द ऑप्शंस यू विल गेट कंफ्यूज्ड. So two or more molecules having same molecular formula but they differ in the functional group, they are called as functional group isomers of each other. Example C3H6O. Now C3H6O दो पैटर्न में दो फंक्शनल ग्रुप्स में अवेलेबल होता है. एक है अल्डिहाइड and the second one is ketone. One is aldehyde and one is ketone, right? तो aldehyde जो होता है, there we have C3H6O. Let us write the structure. Okay, 1, 2, 3. Aldehyde, you know that it is a terminal functional group. या तो यहाँ पर होना चाहिए या तो यहाँ पर होना चाहिए उसका. Okay, I'm writing here the remaining hydrogen atoms. Notice C3, 5, 6, H6O. Now ketone is also there. Ketone. Okay, so again C3H6O. This is 1, 2, 3 propanaldehyde बोलेंगे, or you can call it as propanol also, IUPAC nomenclature. This is propanone. So the name will be, of course, when you study the nomenclature of aldehyde, that time you will understand this. This is propanol and this is propanone. So the molecular formula is same, but the functional group is different, and hence they're called as functional group isomers of each other. Last category is for metamerism. Now it is a different type of isomerism where on either side of the functional group, functional group is there in the center, and on either side of the functional group you have different alkyl groups. Okay, so two or more molecules that have same or different alkyl groups attached to either side of the functional group. So I can say that reading the definition will not help you to understand what is metamerism. When you see the examples, that time you will come to know. Either side of the functional group are called as metamers of each other. Okay, example C4H10O. Now this particular molecular formula has टू टाइप्स ऑफ आइसोमेरिज्म, C4H10 है, राइट? तो एक एग्जांपल ये होता है C4H10O. This is called as ethoxyethane. It is an ether. As you can see the functional group, it is an ether, ethoxyethane. Next one is CH3OC3H7. So this is called as methoxypropane. Methoxypropane. The molecular formula is same, C4H10O. Notice C4H10O. I am not going into the details of naming this because this is overall a different topic, nomenclature of ethers that is discussed in grade 12th. So I'm not discussing that, but I'm just telling you that C4H10 can be written in two different ways and they are metamers of each other. No doubt they have the same functional group, but there are two ways by which we can write C4H10. That is what is important. Done. Now let us talk about the stereoisomerism. Yeah, stereoisomerism. So here the compounds, of course, that have the same molecular formula, but they are arranged differently in space. They are bonded to each other in a type of arrangement that is very different in space. Okay, so right there, two or more molecules that have same molecular formula, but they are arranged differently in space. They are called as stereoisomers of each other. Okay, as I said, there are two types. So usme first wala type is geometrical isomerism. For this also, you have to first see the examples, then only you will understand what we are talking about. First, we'll see geometrical isomerism, right? Now, in geometrical isomerism, there is one important thing that the molecule should have in order to have geometrical isomerism. That is either a double bond or a ring. Okay, so the definition is molecules having same molecular formula but are arranged differently around the double bond or ring are called geometrical isomers of each other. Easy. Example, what are the examples for this? Example, but2-ene exhibits cis-trans isomerism. Cis-trans isomerism. Okay, let us draw the structure. Now you know that this is butene. Okay, H. This is your but2-ene. This can be written in two forms. One is cis, one is trans form. Let us write. So here, as you can see, the structure that I have written is cis-but2-ene. How cis? Because the hydrogen atoms or the similar groups are arranged on the same side of the double bond. This is the same side of the double bond. Okay, both are CH3 or both are hydrogens. However, if I write them differently, it will be like this. This is trans but2-ene. The same groups that are there in the compound are arranged opposite to each other. That becomes trans. If they are the same groups are arranged on the same side of the double bond, they are called as cis. So but2-ene is arranged in cis and trans form, and hence it exhibits geometrical isomerism or cis-trans isomerism. Geometrical isomerism is also called as cis-trans isomerism. Last one, optical isomerism, is discussed again, I will say in detail, in the chapter haloalkanes and haloarenes in grade 12th. Okay, however, we are going to study that optical isomerism. One important thing every compound should have in order to exhibit optical isomerism is chiral carbon atom or a carbon atom that has 4 different groups attached to it. I'll show you how it is. Okay. Molecules having same molecular formula but are non-superimposable but have not are sorry but have non-superimposable mirror image arrangement are called optical isomers of each other. I'll show you what it is. Easy concept it is. You should be having some idea about chiral carbon atom. Example, lactic acid. Now, lactic acid is a molecule where the carbon atom is having four different groups attached to it, like this one. Just a second. CH3, COH, OH, H. Now, this is lactic acid. You know that this carbon which is there here, it has four different groups. Now, I know that lactic acid can be written in this form also. See, CH3, CH, OH, COH. So in that case also, this carbon atom has four different groups, right? So this becomes the chiral carbon. Four different groups are there. One is this, then this is there, then this is there, and hydrogen is there. Okay. So this particular structure, if I keep a mirror here, and this structure is allowed to look itself in the mirror. So CH3, which is arranged vertically, will not get affected. But the OH that was there on the right hand side will now come on the left, and the H which was there on the left hand side will come on right. So how it will look itself in the mirror? Okay, so it will look like this. CH3 will superimpose with CH3. Sorry, I wrote C. Oh wait, I should write COH. CH3 is superimposing with CH3. COH is superimposing with COH. But if you keep the structure on this like that without inverting it, okay, so this H is not superimposing with this OH because they are different. Similarly, this OH is not superimposing with this H, and hence they are non-superimposable mirror images of each other. And that is the criteria to exhibit optical isomerism. The hands, our palms are the example. So these are non-superimposable mirror images of each other. If I keep my palm like this here on this, the fingers cannot superimpose. See, this is my small finger, okay? It is not aligning with the index finger. So it is not superimposable. If I want to superimpose my palm, I have to turn my palm. I have to invert it and then it can superimpose, obviously. But without inverting, I cannot superimpose. So these are mirror images. These are also mirror images of each other. So this is the basic criteria, to exhibit optical isomerism. It is discussed in detail in grade 12th, but till 11th standard, you should be knowing all the four types of isomerism that we have discussed. The first one is chain isomerism. The second one is position isomerism. The third one is functional group isomerism. The fourth one is metamerism. And these are categorized in the structural isomerism type of isomerism. Okay. Hope you understood the lecture. We shall discuss the other topics in detail in the next class. Thank you so much.